Hello class, I'm Mr. Wang Xing. Today, let's continue to learn about air pollution control technology. Chapter 9, Section 4, Control of VOx pollution by adsorption method. In this lesson, we will learn the adsorption method together. This volatile organic compound treatment process. The first is the adsorption process. Mix gas containing VOx. After removing particulate pollutants first, then the pressure is adjusted by the voltage regulator, then entering the adsorption bed for adsorption purification. The purified gas is discharged into the atmospheric environment. When the activated carbon in the adsorption bed I is saturated, switch to adsorption bed 2 by valve. Adsorption. Steam is introduced into the adsorption bed I for desorption. After condensation of desorbed steam or air mixture, separation by concentrator and separator. The desorbed activated carbon is dried with hot air. Recycling, generally reusable for 5 years. This method is suitable for treating VOx tail gas with medium and low concentration. The adsorption effect depends on the properties of adsorbents. VOx category, concentration, properties and operation of adsorption system, temperature, humidity, pressure and other factors. Under normal circumstances, unsaturated compound, more complete adsorption than saturated compounds. Cyclic compounds are more than substances with straight chain structure, easier to be adsorbed. Research shows that activated carbon has the best adsorption performance for VOx. The reason is that other adsorbents, for example, silica gel and metal oxides have polarity. Under the condition of water-vapor coexistence, the water molecule binds to the polar molecule of the adsorbent, so that adsorption performance of the adsorbent is reduced. Activated carbon molecules are difficult to combine with polar molecules. Thereby, the ability to adsorb VOx is improved. However, some VOx are adsorbed by activated carbon, difficult to remove from activated carbon. For this type of VOx, activated carbon should not be used as adsorbent. Other adsorption materials should be selected. Secondly, let's learn the adsorption capacity together. For engineering applications, adsorption capacity, it directly determines residence time of adsorbate in adsorption bed and the scale of adsorption equipment. Through adsorption experiment, available adsorption capacity curve of adsorbate in designated adsorbent. Generally speaking, adsorbability of compounds, its relative volatility, approximately negative correlation. Therefore, a gas stream containing multi-component organic vapor, when passing through the activated carbon layer, in the initial stage, each component is equally adsorbed on the activated carbon, but as the boiling point is higher, increased retention of components in the bed, relatively volatile vapor begins to regasify. After reaching the penetration point, exhaust vapor, most of them are composed of highly volatile substances. At this stage, components with higher boiling points start replacing components with lower boiling points, and each other component is repeated. This replacement process, there are two kinds of airflow, or more than two volatile organic compounds. 1. Adsorption of organic compounds with large molecular weight. There is a tendency to replace low molecular weight organic compounds. That is, the light component passes through the adsorption bed at a faster rate. Therefore, the separation of the light component and the heavy component can be realized. In addition, multi-component vapor adsorption at the same time, the height of mass transfer zone is increased. It may be necessary to increase the length of the adsorption bed, and the retention of carbon may be weakened. When multi-component organic matter is adsorbed, the efficiency of a given system will decrease. Lower explosion limit of mixture will change directly with the lower explosion limit of various single components. Great attention must be paid to operational safety. In multi-component adsorption gas flow, existence, when there are two or more volatile organic compounds. When the adsorption of organic compounds with larger molecular weight, when there is a tendency to replace low molecular weight organic compounds, that is, the light component passes through the adsorption bed at a faster rate. Therefore, the separation of the light component and the heavy component can be realized. In addition, multi-component vapor adsorption at the same time, the height of mass transfer zone is increased. It may be necessary to increase the length of the adsorption bed, and the retention of carbon may be weakened. When multi-component organic matter is adsorbed, the efficiency of a given system will decrease. Lower explosion limit of mixture will change directly with the lower explosion limit of various single components. Great attention must be paid to the safety of operation. Multi-component adsorption exists in airflow when there are two or more volatile organic compounds. When the adsorption of organic compounds with larger molecular weight, when there is a tendency to replace low molecular weight organic compounds, that is, the light component passes through the adsorption bed at a faster rate. Therefore, the separation of the light component and the heavy component can be realized. In addition, multi-component vapor adsorption at the same time, the height of mass transfer zone is increased. It may be necessary to increase the length of the adsorption bed, and the retention of carbon may be weakened. When multi-component organic matter is adsorbed, the efficiency of a given system will decrease. Lower explosion limit of mixture will change directly with the lower explosion limit of various single components. Great attention must be paid to the safety of operation. Let the substance with lower boiling point BA and rho A and rho B respectively indicate that in the air content of adsorbe A and adsorbe B, the gas flow containing A and B adsorbates passes through the adsorption layer. Figures 10 to 26 show that when adsorbe passes through the adsorption layer, distribution of adsorbe along the length of adsorbent layer L_1 is the length of the adsorbed layer for the two substances to be completely saturated. The adsorption capacity of substance A is equal to alpha ab. Alpha ab is the concentration of substance A, and the concentration of substance B is rho B. When in equilibrium, adsorption capacity of substance A, the adsorption capacity of substance B in L1 is alpha B. L2 is saturated by substance A, adsorption layer length that can still adsorb substance B. L3 is the length of the adsorption layer saturated by substance A, wherein the adsorption capacity of substance A is alpha A. L4 is a working layer capable of adsorbing substance A. Adsorption heat of activated carbon. When using activated carbon to adsorb vapor or gas, usually give off a considerable amount of heat. The temperature of activated carbon and airflow increases. The adsorption capacity of activated carbon is reduced. Industrial calculation time. For physical adsorption, the heat of adsorption is often equal to its heat of condensation. However, this assumption will lead to large errors, because the adsorption heat of physical adsorption is equal to the condensation heat, the sum of Q coagulation and wetting heat Q moistening. Only when the current is larger than the latter, the heat of wetting can be ignored. And the Q run here, it is the so-called differential wetting heat at a certain stage, not all the so-called integral wetting heat. That is, Q run here, it is the local surface of activated carbon solid particles, heat released when wetting a liquid, not what is usually given in the manual. Immerse solids completely in the heat released. Therefore, the adsorption heat should be directly checked from the manual, instead of using condensation heat and wetting heat. Then the method of adding actual calculation of adsorption heat of organic vapor. The influence of temperature can be ignored. For some organic compounds, relationship between adsorption heat and adsorption steam quantity, it can be estimated by the following formula. Finally, let's study together rotary adsorption concentration technology of zeolite. Zeolite is a kind of aluminosilicate mineral containing aqueous alkali metal or alkaline earth metal.
酸矿物总称
Unique internal structure and crystalline chemical properties so that it has strong adsorption and is widely used. Industrial adsorbent. Hydrocarbons can be effectively removed. Fatty acids, mercaptans, phenols, organic chlorides, acetone, alcohols, organic waste gas such as aldehydes. Adsorption equipment of this technology. The system takes ceramic fiber as the base material, a large disc wheel system made into honeycomb shape. See figure 1017. Students, through the study of this section, basically understand principle of treatment of VOX pollution by adsorption method and its technological process. That's all for our class today. Thank you all.